Greetings, RadTech students. Allow me to talk to you about picture archiving communication systems, PACS, and medical imaging informatics from Chapter 36 in your textbook. Let's start with your digital X-ray machine. It's going to have three components. It has the acquisition part. You have the tube and the image receptor, and that's going to create an analog image. And then it's going to have to go through the ADC, or analog to digital converter, that's going to convert that analog image into a digital file that can be processed by the computer at the plate reader, or in a DR system there'll be a processor to take in that image. It'll have a server to store it. When it comes up on the workstation to view, it has to go through that same process again, going from digital back to analog. So three components: image acquisition, image processing, storage and display, and it has to be converted from analog to digital and then from digital back to analog. So let me explain how that works and what I mean by that. Hopefully everybody sees an image of President Lincoln. This is how humans view an image. The computer system is going to view it a little bit differently. It's going to take your analog image, which it sees as a bunch of different shades. It's got white, it's got black, it has many shades of gray. It's going to take that image, then it's going to assign a pixel value. These numbers represent pixel values for all of those different black, white shades of gray tones. Once it has all of those pixel values, so it knows how bright to make the pixel on the monitor, it ends up with a simple matrix looking file of numbers. It takes your analog shades of gray, turns them into pixel values. Then it can store it, or it can convert it back to an analog using those numbers and bring it up on a workstation so that the workstation displays exactly what your analog image was. So, important to note that between storage, how it's being stored as a digital file, to display, you have the DAC, or digital to analog converter, that takes that digital numeric file and turns it back into a human viewable image. Okay, so PACS, through that process of digitization, images from all different modalities can be stored on magnetic tapes, discs, and optical discs. PACS is possible because of that process of converting analog files to digital files. And this enabled the development of the system called PACS that can retrieve images, display them for viewing, transmit them to remote locations, and provide archival storage. It's the PACS system. When two DICOM modalities, or a modality and a PACS, get together, there's two sides to that conversation, right? So you have a service class user, and this includes image acquisition units that make use of a centralized storage system. They are users or requesters. They're requesting a service from PACS. Hey, can you store my images? And you have service class providers. These include all centralized storage and distribution services and the PACS workstations that allow them to access. So every time two DICOM type devices, applications, servers, anytime two DICOM devices are communicating, you always have a service class user and a service class provider, and the conversation goes something like this. They get together, the user will ask the provider, do you speak DICOM? The provider will say, yes, I speak DICOM. The user will say, can you store my images? The provider will say, yes, I provide that service. I can store images. And so once they talk to each other in DICOM, find out they speak the same language, then the user will request the service from the provider. That's SCUs and SCPs. We're going to break this into 3 videos. Thank you for watching part 1.